In the name of Allah, the Compassionate and the Merciful. Hello guys. In this video, we're trying to have an example of geometrical and material nonlinearity analysis of 2D truss with force control and damage index control in C and Matlab programming, and then we're trying to verify our example in Seismostruct and ABAQUS. You see, we have the 6 elements to the truss, and with indicating of materials nonlinearity as a strain and stress relation, and deformation shapes with indicating of material nonlinearity. We applied the load in the degree of freedom number 5 in node 3, and then we see all result and compare it with each other, and you see at the end all the data with pushover analysis based on base shear and displacement force control. You see the all codes is available, C code. So we can have an in here our C code. You see I defined many functions for inputting data: length, height, force, initial force, iterations, tolerance, importing data of each stress and strain relations of these elements, and for example, for the solving our matrix problems in for example, for inversing matrix, for internal forces, for all types of functions, I defined many void as a function. You see in here all importance data is available here, and also we have a Matlab code in here. You see in here data shows the strain and stress relations of each element and area of each element. You see in here, and you see all the slope of this actually tangent elastic calculated in here, and you see that in here we determine the maximum strain for our future analysis, and then you see in here for each step of our incremental force all length is changed, angles are changed, and then stress and strain relations is changed, and then each element of this the 6, actually we have you see that we have 6 elements. So in each 6 elements materials properties and geometrical properties is changed. So in here we have a total stiffness. You see it is assembled based on each degree of freedom, and then inversed, and you see at the end we're trying to have a convergence problem in here, you see, and at the end we're trying to have an output of each element for showing and outputting our example in Matlab. So you see that outputting our C programming output in here. You see in here we have many increment table, iteration, reaction, displacement of each node in each directions, outputting of our displacement in Matlab, you see in here. And then we want to verify our example in Seismostruct. You see I defined element properties. I defined circle area and applying load in node 3 and restraint and node 1 and node 2, you see in here. And then after analysis, showing the element deformation and force of each element. And you see in here the pushover analysis result based on our analysis in Seismostruct. And also we defined and analyzed this example in ABAQUS. You see stress and strain relation is defined in here, applying loads and restrain in node 1 and node 2, and you see yes, restraint in here. You see that boundary conditions in ABAQUS, and you see we defined for our better converge we defined the mesh in ABAQUS, and at the end the result is shown, and you see the deformation in ABAQUS. All data such as Matlab, C, Seismostruct and ABAQUS is available in the site is available. You can use and define it with your own and change it if you want. You see that in here we have an ABAQUS file. So you see in at the end section you see that all properties is shown as a displacement and base shear, you see in here, and